Hi everyone, we are the team. Attention please. Our work is to find meaningful app data for business and users. My name is Zhao Wei. The other team member is Chen Pongyao, Li Yuan, and Yumi. The whole presentation includes 5 parts: the dataset we use, design implement, business part, and user part. Finally, the conclusion. The dataset we use is a subset from Yap's business, review, and user data. The details of Yap dataset is shown above. For design implement method, radar chart, heat map, bidirectional histogram, parallel coordinates, water cloud, map, and river metaphor visualization is used. The programming tools include Python, Plot.ly, and HTML. For business part, there are 3 tasks. 1. Analyze the half-month emotional opinions from customers for stores during the past 1.5 years, using bidirectional histogram. 2. Analyze the different stars numbers in the past 1.5 years, and the corresponding comments, using river metaphor and word cloud. 3. Analyze the relationship between the days and the crowd list, using calendar heat map. For calendar heat map, we take the check-in data in Yap dataset to process. The data structure of check-in is shown in the left. It has 2 attributes, business ID and date. Business ID is the primary key of a local business. Date represents a user has a check-in in that day. For data processing, first, we select a specific business and then sort the check-in into date value pairs, which is shown in the right. The encoding scheme of calendar heat map includes 3 parts. Color. 5 color represents different levels of crowd list from 0 to 300. Shape. 1 square represents 1 day in a year. Dimension. X represents month. Y-X represents Sunday to Saturday. And we find that the number of check-in in 1 day of a year varies. Crowd list focus on Saturday and Sunday. When holidays come, the check-in will rise. For interactive usage, there are 2 methods. First, owner can select 1 specific day to know the number of check-in in that day. Second, the owner can select 1 color level to know the distribution of this crowd list in the whole year. For example, we can select 1 specific day to know the number of check-in in that day, and then select 1 color to know the distribution of this crowd list in the whole year.
Okay, thanks Zhao Wei. My name is Chen Pongyao and I'm gonna in charge of the next part of a business to you. For this part, we choose 2 specific business stores to visualize their storing performance in the past 1.5 years. The first visualization for those 2 businesses is sentiment analysis of reading. The encoding scheme is comprises of colors and lengths. The blue encodes positive reading and red encodes negative reading, and the length encodes the values for 15 days reading. And what is the reading from? We calculate the average star for store 1 in the past 1.5 years. Subtract these averages for stars of every day. If the result is positive, it will be blue, and the average time stepped in this visualization is 15 days. Thus, for stop 1, negative opinions is more than positive opinions, but it is not bad as a whole look. And from 2018, August 14 to August 29 had the most positive opinions, and from September 14 to September 29 had the most negative opinions. So we can make reviews from this good or bad performance days. And for the stop 2, negative opinions is always more than positive opinions. And from 2018, May 14 to May 29 had the most positive opinions. And from March 14 to March 29 has the most negative opinions, so we can also make reviews for these good or bad performance days. Okay, the next visualization is customer rating review. The color encodes different star intervals, and the real encode the counts for each star intervals in 15 days, and the word cloud is main test for customer comments. So we can find that the stars are concentrated on 1 to 3 stars, and comments are talking about food, like that food, pride, and belly grades, buffers, and so on. And the comments from 4 to 5 stars, like that, are talking about vegans, dessert, food, and so on. And for the star 2, we can also see the word cloud. The stars are concentrated on 3 to 5 stars. Comments are talking about rooms and hotel and service and beautiful and amenities. But the comments from 1 to 2 stars are talking about the time, the managers, the hotel, and staff. So this is my part of the business.
Hello everyone, my name is Li Yuan and I am the group leader of this project. And now I will introduce the second part of our project. In second part, we want to help users to intuitively understand the difference between the different restaurants, to help them do choice and compare the restaurant easily. And we use 4 plots to realize it. Firstly, we clean the data by passing package NLTK to extract the feature from the review test. We clean the format of the sentence, take the words, remove the stop words, and put the stem. And then we can get the useful words of each sentence. And secondly, we will feed all data into the LDA model. LDA is a topic model. It's a mathematical method for streaming topic of words at the same time. It can find the mixture of words that are associated with each topic. We'll also determine the mixture of topics that describe this document. Both of them are followed with directly distribution. As it's a little complex, I won't talk more about its detail. After LDA, we can get key topic with n words in each topic. In our project, the key is 8: location, open, environment, value, test, food, service, feeling. And there are some words in this 8 topic. And then we can compute the score. For example, this business has 2 reviews, and the port words in the first review and the food words in the second review. Both of them belong to the food topic, and then we can compute the average score is 3.5, and when we can see the food category for this business is 3.5, we can get a table like this. And then we can, after we collect the data, I will take the city Las Vegas as the example. And our project is on this web. And firstly, we use a map. As you know, the map is the best format to show the location. And for user, he can select the ideal restaurant and our map supports room in and room out, and also it supports the user to use the north-south select. It's here to select some sublist of this location, and then we can get a subset of all candidate restaurant. Secondly is a parallel coordinate, because the business data is high dimensional data, so we use parallel coordinate to visualize it, and each line of the here is a specific restaurant. The red line means the star is higher, and the green line means the star is lower than the others. And for example, I can only select the restaurant in which environment is higher and 4, here and 4, and the test is higher and 4.5, and the service is 5 point, and also the filling is higher than 4. And we can see after filtering, we only have 3 restaurants, and then we can compare them easily.
I'm Yumi to present the detailed comparison visualization after checking a user preference by rough selection step. User can compare details through 2 visualization graphs. One is word cloud to display positive and negative text from review comments. Word cloud displays how frequently words appear in reviews of each restaurant by making the size of each word proportional to its frequency. We provide 2 word clouds, which are positive and negative, to visualize more useful information for the user's decision. To implement these, we classify the review and text with their sentimental value as positive sentiment and negative sentiment by the Python text block sentiment method. Using 2 colors, green and red, to represent each restaurant. Using contrast images, thumbs up representing positive and thumbs down representing negative. Also, user can get detailed text information about the menu or fillings which other visitors left in reviews. Another is a radar chart to compare 7 topics of the selected restaurants. Radar chart is useful to compare multiple quantitative variables, especially the data sets scored high or low. Additionally, the user can see which variables have similar values or any outliers. Radar chart color is the same as the word cloud to make the user perceive each restaurant's result. 2 restaurants considering tasty with taste score over 4.5, food score over 4.5. The user can compare the detailed scores of other topics that the user doesn't consider important, such as services or environment. In summary, we use different visualization tools for business owners to help their business and for users to provide useful information to decide where to go. For the business owner, they can monitor the flow of customers interactively with the number of check-ins a day via HTML, and also they can get the crowdedness information to gain insights about when was the busiest day and when was not. And also, they can monitor the trend of stars and reviews by customers periodically. For the users, they can check the nearby restaurants in a map and make rough choices from various decision factors such as location, taste, and stars. And also, they can check positive and negative review words and compare the restaurants easily with a radar chart at first glance. Currently, it's difficult to connect the results from the rough selection by parallel coordinates and detailed visualization due to plot.ly doesn't support to display the filtered results of variables. So, it's better to do more future work using another tool such as D3 to provide more interactive visualization for users. Thank you for your time to watching this presentation.